Welcome to the session 3 of Unit 4. We have been talking about market equilibrium. Now, in this particular session, we are going to look at market equilibrium using what? Algebraic analysis. Alright, that's what we are going to look at. At the end of the session, we believe that you should be able to write down the demand function algebraically, and you should be able to write the supply function to algebraically, and you should be able to show and explain how to attain market equilibrium. So let's get started. How do we get market equilibrium? We are looking at the algebraic approach. Since quantity demanded depends on only price, as when all other things are held constant, we can write the quantity demanded function or quantity demanded as a function of price. So quantity demanded QD will be a function of price F of P. And the demand curve is represented by the functional relationship. We know that the demand curve shows what a downward sloping relationship. We are talking about negative slope, negative relationship, or inverse relationship. So we are going to have the slope here as what minus. So this is the function for the demand curve, A minus what BP. The A stands for the autonomous consumption, which is not influenced by price. So here P is the price and QD is the what quantity demanded. A is a constant, that's what we mean autonomous. That is the intercept of the quantity axis. And B is the slope. And since it's a downward curve, the slope should be negative. That's why we have the minus B. So the minus is just depicting that we have a negative slope. Note that the demand curve needs not to be linear. It's not always that it to be straight. It can be, slanted in a way. And similarly, the supply curve is also represented by this. We have the minus C plus dP. The supply curve is positive, and so its slope, that is the P, is what? Positive. So in all, the complete model for price determination is therefore, as we have here, that of the demand is this, that of the supply is this. These are behavioral equations. Now, for equilibrium, the equilibrium condition states that the quantity supplied should be the same as the quantity what demanded. QS should be equal to what? QD. Where QD is the quantity demanded and QS is the quantity supplied, and P is the price of what? The commodity. So in this case, we can represent both QS and QD by just, I can say Q will be equal to QS, which will be equal to QD. And I know my QS is what? Minus C plus dP. And QD is positive A minus what? BP. This BP is not blood pressure. So at equilibrium, when we equate this, we can group like terms or group the P's and make the P the subject. So I can say, if I assume I want to make the P the subject, I can bring the P here, the minus the BP. When it crosses the equal sign, it becomes what? Positive BP. Then I'll have my A. When the C crosses that equal sign, it becomes what? Positive C. I want to make P the subject, I can factor P out here. So that I have D plus what? Plus B equal to A plus C. Now making P the subject, I divide both sides by what is in the bracket, that is the D plus B. So I have A plus C over what? D plus B. So my equilibrium price can be A plus C over B plus D or D plus B, however we make it. Addition is commutative. And the equilibrium quantity, we can replace this P we have gotten here in either the supply equation or the quantity demand equation. So assuming I slot it into the quantity demand equation, the quantity demand I have QD equals A minus BP. So I'll put P as A plus C and then B plus D or D plus say B. So in here I'm going to have A is equal to A minus B out bracket open A plus C over B plus D. It's either D plus B or B plus D. Addition is commutative. Okay. So this I can go on and factorize this. So I have something like A over 1. Then this will give me, assuming I'll make it this, so AB plus BC. This B will just multiply the numerator part of the fraction, and I'll have my B plus D. I'll close my bracket. Now, what will be the LCM? What will be the LCM for this? The LCM will be B plus D. Then now 1 goes into B plus D times R. So I had A, this. Then the LCM BD will go into BD times. So I'll still have my I expand AB plus BC all divided by what? B plus D. That was what we had. Okay. So here we can have AB plus AD minus AB plus what? BC minus BC. Because this minus will change this to minus and I'll have B plus D. So this AB will cancel this AB and I'll end up having AD minus BC over B plus D. What were we finding? We wanted to find the equilibrium quantity. So this expression is in terms of only parameters. Now in the next session we will solve with actual numbers, so you will understand. I'm sure that some of you are confused here. Anyways, you know what, in the next session you will understand it more. So see you in the next session. Until then, I say thank you.